Hi, in this video I just want to agree with the basic sentiments that Sal was mentioning in his answer to the question, why all the letters? And I agree that you don't have to use letters, you can use drawings or anything. Actually, I use drawings for variables a lot in my math classes and some of my economics classes in math. One other more powerful thing that it allows you to do whenever you can use symbols, and this is a little more general, when you can use symbols for things like square roots and variables and other operations like addition, subtraction, and multiplication, it gives you a shorthand that allows you a lot more power whenever you're doing mathematics. It allows you to express very complicated ideas in a much simpler way. And that's the thing that I would like to add to this answer and add to this discussion. When you go back and you read some of the early mathematicians before we had the standard algebraic notation, whether it's Newton or Euclid or any of the other famous mathematicians, they would use several pages to describe what we can represent in a very simple equation today. I'm going to just give you two very simple examples about how mathematical notation is much easier to read and easier to understand. When we get into more complicated functions, you can certainly understand that the savings in time and the clarity would be even greater. In Euclid's Elements, written thousands of years ago, he gave us the foundations of many of our many of the things we currently know about geometry and number theory. And one of his very first statements was common notion one. This is basically an assumption he used that he thought was obvious to everybody. And he phrased it this way: things which are equal to the same thing are also equal to each other. And this is a very common notion that we use today a lot. But instead of using this long wordy explanation here, we would just say something like this. We would say, well, if A equals B and A equals C, then B equals C. And this is a much shorter, if I can correct what I typed there, this is a much shorter, much clearer way to write this wordy sentence. It's a lot less than half as long, and this is much clearer what it means. Just one other also very simple example that's in the similar vein. His proposition in book 1, proposition 20, he says, verbally, in any triangle, the length of any two sides taken together in any manner are greater in length than the remaining one. Now, honestly, even though this is a very simple idea, it will take you a couple of times reading that carefully to really understand what's he trying to say. And when I show you mathematically, you'll say, oh, that's simple. Why didn't he just write it using letters? Well, because they didn't have that kind of idea, that kind of structure back then. But what he is saying here is very simply, for any triangle, and we could even draw a picture of a little triangle there instead of writing out the whole word with some of our more modern notation, but for any triangle with sides A, B, and C, A plus B is greater than C. This is a much shorter, much more clear way to write exactly the same idea, and you only have to read this, for any triangles with sides, and if you want to make it a little more clear, of length, right? For any triangle with sides of length A, B, and C, A plus B is greater than C. This is what we call the triangle inequality, and it's much clearer to write in a much shorter notation using letters and using some symbols than it is all these words here. So I hope this helps you understand one additional reason why using letters in things like algebra and even geometry is helpful and aids in our understanding.